So guys, in this next segment, we're going to take a look at enterprise value multiples again, and we'll review some of the ground that we covered on Monday, as well as go just a little bit further into the equational form and try to put some perspective on this. So I'm going to go ahead and share my screen so you can see the PowerPoint. We'll walk through that. So in this, you'll remember that I introduced to you a class of enterprise value multiples when we spoke on Monday. And here I give you four different examples of them: a revenue or sales multiple, an EBITDA multiple, an EBIT multiple, and a free cash flow multiple. If you look at the valuation multiples quick sheet that I've given you, you'll see there are 4 or 5 others, but they're rarely used in valuation, and they're rarely used when it comes to thinking about equity in firms and stakeholder value. And so that means they're not often used when thinking about executive decision levels in the firm. So I'm going to focus on these 4 with our class, and specifically we'll focus on the EBIT multiple. Sometimes these are referred to as EV/EBIT, EV revenue, EV free cash flow, but more often than not, they're just referred to by the denominator, recognizing that enterprise value, or EV, is always the numerator. So I told you that if we can think of this ratio of some enterprise value divided by some EBIT as a multiple or as a ratio, we can call that M. And just looking at it in that form as I have here within the PowerPoint, that's not a model for value, but when we rearrange the equation, multiply both sides by EBIT, then we turn it into a valuation model. And so if we have a ratio or a multiple that we know we should be able to apply to our firm and its EBIT, we can take that ratio, we can multiply it by EBIT, and we end up with some enterprise value. Now, this is not simply the value of the stock. This isn't a price earnings multiple for stocks. This is the entire enterprise value of the company. And we know that enterprise value would also be equal to the market cap of the common plus the market cap of the preferred plus the market cap of the debt minus cash. So if we know that, and we can then come up with this enterprise value, we can then parse it out to find different things. Maybe we would use this as a way to help us find what the value of the company's equity is. And if we know the number of shares outstanding, we could go further and find a price or a value per share of that equity. But at this point, it's just enterprise value. And we recognize enterprise value as the entire valuation for the firm. In fact, we also know that if we think that a firm's growth rate is going to be constant, then that means all we need to do is use this model to find that value for that firm. Well, that's a very simplistic way of looking at it, of course, and it's probably a very broad brush with which to paint, but nonetheless, it is that. In fact, think of this as one of the ways of finding an enterprise value, finding a continuing value, a terminal value, a continuing value. We've looked at continuing values or terminal values before using the Gordon growth model, finding some cash flow, dividing it by WACC minus G. And then we either apply that today immediately if the company's growth rate is expected to be constant, or maybe it's one that we find out in the future and have to discount back to today if we've already used some explicit period as well. And we'll find that the enterprise value multiples, the way that we would use them as valuation models, runs the exact same gamut. This is a continuing value. It's either a continuing value today because growth is constant, or it's a continuing value that we might think about using sometime in the future. Now, I'll put some numbers to this that we have from the Mira-Dravana example, and you have that spreadsheet, of course. When we observe the base year, we see that the EBIT multiple is equal to 9.28, given a 288.31 enterprise value and a 31.063 EBIT, so giving us a 9.28 multiple. Well, what does that mean? Well, I don't know that it means a lot to us at all, other than it's an input that we might choose to use if we're trying to estimate the value of the company. So if we know what the multiple is, or maybe we know what it should be, and if we can look at a given year's EBIT, say EBIT for time 1, then that tells us the value of the firm, and in this case, it would lead us to a value of 317.088. Now, you might remember that the other valuation models that we've used for Mira-Dravana have led us to a valuation of about 150, 149 point something. So this valuation at 317 is dramatically different. It's more than twice as high. And I think we need to start to ask the question, why? Well, that's at the heart of what exists inside of these multiples, if you will. Before we get there, let's talk about how we select the multiple, and then we'll get to a point of thinking about what their relevance is. So we can look at a point in time in our company's history. Maybe it's the most recent year. Maybe it's an average of a number of years. Maybe it's some point where we were performing very well and we had a multiple of 7, and now our multiple is down to 4 and we want to get back to 7. Maybe we would use 7 as an aspirational target, either from our history or from some other company that we want to mirror. Maybe I'm looking at this and I see that WAR Enterprises is trading at, or is reflective of, a valuation multiple of 9. And I look at my company and I say, well, we're not performing as well as WAR Enterprises, but I think we can if we would up our game, if we'd be better at management, better at innovation, if we would be more proficient, more efficient, then maybe we can aspire to having the same kind of growth, the same kind of efficiency as WAR Enterprises, and that then will allow us to consider reaching that multiple that WAR Enterprises had as well. So we can use our company's history, either at a point in time or average over a period of time, or we can select a target in the industry that we're in or some other company and say we'd like to be like that. We think we can become more like that if we'll change our management, our innovations, etc. And that's an aspirational target. Or we can look at other companies that have had transactions recently. And any company that's in the public market has transactions every hour, every minute, every day, sometimes every second, right? But many companies in the private markets don't have that. They've had recent transactions, and those are picked up by data repositories. Private transactions are picked up by Deal Stats. Public transactions are picked up by PitchBook and by FactSet and Capital IQ and Bloomberg and such. And we can look at those companies, public and or private, that kind of like ours. Let's say we've got a shoe manufacturer. We can look at all other shoe manufacturers and we can see at what multiple their value is reflective of. Because if we see a transaction for them, then we can cause that transaction. If it's only a share of stock, we can extrapolate it to the entire enterprise value for the company. Or if it's a private company, the transaction price that we're seeing probably is the enterprise value for the company. We can go ahead and use that, and we can divide it by, in this case, EBIT, and it gives us a multiple. And so we can see the valuation multiples of other companies that are similar to ours, and then we can either take the average of those, or maybe we rank these companies based upon, let's say, operating performance, and we take the average of the quartile of those where we most closely align, and that could be a comparable value. And so this maybe is where we would find some of the multiples that we would apply to our company if we don't have other good mechanisms ourselves. And then finally, as we've talked about before, we can look at the algebraic form of the multiple, and we can calculate it. And that will give us maybe a number that is reflective of some other input. So let's look at this. I showed you on Monday this little table. Again, this is an abbreviation of some material you have in the valuation multiples quick sheet. It's also found in that valuation poster that you see hanging on my wall. I shared with you a PDF, or maybe it was a JPEG of that some days ago, so you have it, and it's linked in Canvas. But we'll just focus here for a moment on the EBIT multiple, and and we recognize the EV/EBIT, when we express it as a number, as a multiple, is equal to ROIC minus G divided by ROIC times WACC minus G, all of that times 1 minus the tax rate. Now, when we spoke about this on Monday, I didn't go through the algebraic proof for you. I didn't even offer it to you, but in a moment I'll show it to you and we'll discuss it a little bit. But if I know what the EV/EBIT multiple is, I can reverse engineer to G if I would like to. Or if I believe I know my company's G, and I certainly know its ROIC, I certainly know its WACC, I certainly know its tax rate, I can estimate what kind of a multiple our company should have, because it's reflective of our return on capital. It's reflective of the relationship between WACC and G, and it's reflective of our own growth, and we always have to deal with the reality of taxes. You will be responsible to think about this equational form, and you'll be responsible at a point to calculate an enterprise value multiple from one of these. I might give you the equation, or I might just give you hints with respect to the equation. Let's walk through a algebraic proof on this for just a moment. So I don't give any numbers to this. This is just a proof, so it's not us calculating any numbers, but it just kind of gives you a sense of where we start and how we get to the end here. So we start with this concept of enterprise value, or continuing value, if you will, could be equal to no plat times 1 minus G divided by ROIC, and all of that divided by WACC minus G. Well, that's a Gordon growth model using the KVD form of free cash flow. So that's where we start when we're trying to put together the algebraic form of these multiples. Well, in this case, we're going to take the next step by breaking no plat down into its component parts of EBIT times 1 minus T. So we substitute that for no plat. And then we're going to go ahead and divide both sides by EBIT, which leaves us with the EBIT multiple on the left-hand side and its algebraic form on the right-hand side. And you can go ahead and stop right there. And you would find that that is an accurate calculation, or rather equation, for the EBIT multiple. You'll find in most cases that it is extrapolated further by just working through some of the algebraic tools that we have. The next thing that I do here is I take and substitute, well, I take and move that 1 minus T over to the right, so we're still multiplying by it. I take and substitute ROIC divided by ROIC for 1, because anything divided by itself is equal to 1. When I've done that, I can then simplify that equation, as I do in the next step, to ROIC minus G divided by ROIC. And that divided by WACC minus G, and all of that multiplied by 1 minus T. And then when I do some additional reorganization by multiplying both the numerator and the denominator by ROIC, I end up with ROIC minus G divided by ROIC times WACC minus G divided and multiplied by 1 minus T, which is the equation that we see here for the EBIT multiple. That's an interesting equation for us, because again, it lets us not only estimate a possible value for the multiple, and maybe we'd use that estimation, but it also lets us, if we know what the multiple value should be, if we've got either from history, comparables, or from some aspirational target, we know what the value should be. It lets us reverse engineer the one variable in this equation that we're the least confident about, and that's the long run G. So think about this. You'll have an opportunity in one of the upcoming problem sets to use this, and you'll have to think about it when it comes to thinking about the final exam as well, because some of this becomes highly interpretive, and it's the kind of thing that we will be spending a lot of time on.